Well, good afternoon, everyone. As you know, my name is Kenrick Sylvester, and I'm Principal and Head of Distribution here at Infor. It's my pleasure today to introduce Equispheres to the Wellington Altus team. So Equispheres is an Ottawa-based materials science engineering company specializing in the development and production of high-performance metal powders for additive manufacturing or 3D printing. So these aluminum metal powders are used to produce stronger, lightweight components for the automotive, aerospace, and defense industries. So what's interesting here is their core IP is centered around the proprietary spherical powder, which prints 4 times faster and achieves cost reductions of up to 50%. So the goal here is to enable additive manufacturing technology to compete economically and ultimately displace traditional manufacturing processes, which are less efficient. So with us today is the CEO, Kevin Nichols, and Ruth Bengoff, the CFO, to walk us through this story. Thank you very much for your time.
Thanks, Kenrick, and welcome everybody. Sounds like from across the country, which is great. So just to give you a little bit of a primer on Equispheres. So we were founded back in 2005 on the idea of a new technology tailor-made for the needs of what was going to become metal additive manufacturing, just 3D printing of metals. Over that 6 years, we've raised about $61 million, including a $6 million grant from Lockheed Martin and $8 million clean tech grant from SDTC. The first 4 rounds were from Canadians across the country. We've had a really great track record of hitting our milestones, creating value, and steady improvement for shareholders along the way. We've been working with the world's leaders, literally in aerospace, automotive, and defense. Pretty much all the relationships you'll see today were all inbound demand. So back in 2016, when we had first revealed our new technology and the material that's made from it, we had 20 calls from billion-dollar companies asking, how did we do it? And obviously we were very early and we couldn't ship a lot of it at that time. So we've been sort of building up these relationships, the IP, the validation, until this year, where we're bringing online our commercial reactor products and starting to supply the market. So you sort of see some of these highlights here, so I won't try to read them all out for you, but we're in a really neat spot. We're in a market that's just inflecting now, and we're at the right spot in the value chain, just at the right time, we feel. So I know a lot of people haven't seen 3D printing of metals before, so there's a good 70-second clip here from GE, which I think explains it really well. And it shows you basically how companies are going to make parts from powder instead of your traditional sheet and different materials.
What is additive manufacturing? Additive manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design, or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work.
So hopefully that's helpful to explain how this process works. Now, so what Equispheres does is we have a technology that's completely unique and solves the key problems faced by the industry in using metal powder. So the applications you see in front of you are the reasons that people would 3D print metals in the first place. And a lot of them revolve around, lightweighting. So you can make pretty much any part lighter by using in 3D printing, because you can put material only where you need it. You can redesign your parts to be more cost effective, to use less material, to be lighter, save fuel. And on the right side, you can see how traditional manufacturing, in the GE example, you've got 8 components there that are made separately, cast separately, and then assembled, where you can make a better component that does the same thing in one shot. So there's all these great examples of consolidating parts and simplifying manufacturing. One great example being the GE catalyst jet engine, where they reduced 855 parts into 12. So, you know, one way to look at that in manufacturing is that you do everything this way if it was fast and inexpensive enough. So it's all around sort of the speed. But when they talk about replacing, you know, the multi-hundred billion dollar casting market with 3D printing of metals, I don't think anybody disagrees that this is a better way to manufacture, to reduce inventory, supply chain, lightweight. It's really just an issue of how fast and when. The supply chain end of it has really been heightened the last year. So you hear a lot about onshoring, reshoring, and 3D printing of metals fits that to a T. A lot of you might be more familiar with 3D printing of plastics. So plastics are typically used for prototyping, one-ofs. I mean, they're everywhere, every school, every university, even, you know, companies have them to prototype their consumer products. But 3D printing of metals is all about industrial, you know, serial production of parts used in production. So the market's much, much larger, much more industrial based and more technical. There's more technology, lasers, high precision, everything. So the advantages, as you see them on the right here, is that an example I used earlier today was that the ability to have what you need where you need it is very powerful. So you've all seen that Apollo 13 movie where, you know, they throw all the parts on the desk and go, well, we need one of these that fits into one of these. How are we going to do that? Well, the space station has a 3D printer on it for that kind of reason, as a proof of concept that you can print what you want, where you want it. And you think of the military applications, and that's why the US Army is working on this pretty heavily, where you just have 3D printers in containers with powder in the field, and you're getting rid of all of these difficult logistical issues that go with moving people all over the world. So the market is you know, really just going to grow and grow and grow. The key inflection points are the speed and reliability of the process. You couldn't find any defense, aerospace, or major automotive company that wasn't actively or heavily involved in it. There's billions of dollars been invested in to start to change over their manufacturing. And I think what you're going to see is the next year is going to be the real inflection point in this business. You can see it from the investment coming into the kinds of companies that are helping make metal 3D printing faster. So these are some examples here. So, you know, the market is valuing speed. So whoever can help make metal 3D printing fast is attracting a lot of investment. So a couple of examples would be, you know, Arcam on the left there. So that's a Swedish company. A bit of a Canadian story here too. They purchased, I guess it was the only other metal powder company at the time in Canada, called Advanced Powders and Coatings out of Montreal. So they purchased Advanced Powders and Coatings for $35 million on about $5 million of revenue back in 2016, 2017. And then Arcam was bought by GE for about $1 billion in 2 tranches, with, I think, negative EBITDA at the time, I believe. And Desktop Metal is the fastest unicorn in US history. So they make high-speed 3D printing, metal 3D printing machines. So those high-speed machines print about 100 times faster than traditional metal 3D printing machines. So they've got investors, you know, all the big names, whether it's the Googles, the car companies, Coach Disruptive Technologies are all in there. And X1 below that, similar high-speed metal 3D printing. There's a lot of companies out there that are into plastic printing, and it's really important to think of those a bit differently. They're not really industrial, you know, companies. They're in a really bit of a different market. So Equispheres, you know, I put those right at the top of this group in terms of its importance, because there's no company out there that is speeding up metal 3D printing more than we are. And we're doing it for all the different technologies. So whatever technologies or company that you think, it might be the bad, we believe that it's all going to go through the technology that we've brought forward. There's one other powder company in Canada today that trades. One's Pyrogenesis. I think their revenue is under $10 million. They're having a valuation of something like $1 billion right now. They pivoted into metal powders, I think a couple of years ago. I can't speak to that valuation, but there's certainly a growing understanding that the powder is really the key part of the value chain. So Equispheres, we're really different. So when you think of the competitive landscape, if you're us, there's two technologies that make metal powder. So those are called atomization technologies. There's billions of dollars of powder sales globally. So powder's not something new, but this technology was invented a long time ago, before laser 3D printing or any of these 3D printing measures were conceived. So those technologies are poor at making powder that is necessary for metal additive manufacturing, 3D printing. So when we first published the images of our powder back in 2016, we had inbound interest, inbound calls from, major aerospace, defense, NASA, Oak Ridge Labs, the big materials companies, all saying, how did you do that? Because they all had problems in what they were doing, that they had a pretty clear understanding of what would solve those problems, but nobody had ever seen powder like this before. And, it doesn't take a ton of imagination to imagine that, you don't have a lot of processes that are high precision, that rely on a material that's inconsistent. So on the left side, you'll see traditional powders. So those are powders made from other technologies. The powder is all sorts of different shapes and sizes. A lot of it gets stuck together. And you imagine putting a laser beam across that and trying to create a very consistent melt of material to make a part. And it doesn't really work that well. You get inconsistent mechanical properties, you get little holes in the parts that lead it to crack initiation. And all those little powders they're actually hazardous, explosive. They actually use them in the solid rocket fuel boosters of the space shuttle. So nobody wants those fine powders. They're a hazard. So our process creates a powder that is fine free and that is uniform. So intuitively, it right off the bat, it made a lot of sense back in 2016 when we started out. The net result of it, sort of at the high level, is that you can print 4 times faster with our powder. You can make parts that are 30% lighter, and we're able to reduce the cost of printed parts by 50%, all on our own, which is a huge step forward for the commercialization and just the rapid adoption of metal 3D printing. And again, we have great clean tech credentials. We use less energy into making the powder. We make parts 30% lighter. We had that $8 million grant we had from SDTC, Sustainable Development Technology Canada. It was the largest one of the year for them. Our lead partners are BMW and MDA. And that was 6 months of validation by a variety of scientific panels. So on the left side, you'll see there's sort of traditional manufacturing of how people make metal today. There's a whole bunch of different steps that go into assembling or making a metal product. The future is on the right, where you're basically atomizing powder, turning it into a powder from a raw feedstock, and then printing it. So much simpler steps. And in the printing end, there's been a ton of momentum on the investment on that end. But the atomization technology part is the part that's really missing from all of those processes. So on the right side, that's a picture of our commercial atomizer that's coming in June, July this summer. So that's a big step forward for the company. We've currently been working with these atomization reactors that are 26 feet tall and humongous. So this is a result of probably about $10 million of investment into miniaturizing and commercializing our technology. And that's coming online this year. So we're excited, and we've been working towards this point for several years. This is sort of another slide showing you the difference in the cost. So, 3D printing of metals today is, it's slower and expensive. So that whole light blue area underneath is the bulk of the cost, and it stands to reason if you print 4 times faster, that you're reducing the cost of the overall process. And there's all sorts of other benefits aside from that, like the safety aspect, the repeatability of the process, that you don't have to worry about having inconsistent mechanical properties in your parts. But we really focus these days on how important the speed is, because that's what's really going to kick off the mass adoption. We spoke a bit about the clean tech benefits already. So one of the challenges with traditional atomization technologies is that since the powder is made so chaotically, most of it goes to waste. So when you looked at the competitive powder that we showed you, that was sort of the best 30% of it. The other 70% is not applicable for additive manufacturing because the powder's just too variable. So our process produces a much higher yield of saleable powder. So you have less energy input, makes parts that are 30% lighter. And it actually spurs on the whole adoption of metal additive manufacturing to higher levels, which, has tremendous, weight savings in automotive and aerospace. These are some of the customers that we work with other people than this, but we can't talk about all of them. So our whole strategy from the beginning is work with the leaders, the end users that are the most advanced, so that we're the standard for powder that's going to be used in the process. And then it's pretty easy to imagine everybody else sort of follows the lead of that. So, all these people here, there's not very many new relationships here. These are all ones that have been working with us, testing our powder, building relationships, and building up to our commercial offering. You see the third line, you've got the Desktop Metals, X1s, HPs, those are companies that are really leading the foray into high-speed metal printing. Trump is a leader in the industry that's currently qualifying our powder. Important to note that this whole business plan that you're seeing is all just aluminum powder for additive manufacturing. So aluminum isn't even one of the largest materials at the moment. It's things like steel and titanium. One of the reasons is that aluminum has been so hard to get in a good powder. So there's going to be tons of substitution into aluminum. And even without the substitution, it's clearly the one that everybody wants, because everybody wants to use aluminum in cars and planes because it's the lightweight material. So we're really unlocking, a lot of pent-up demand. So there's the other materials that we can go into. The Eagle Picture one is one that's an inbound interest for solid-state batteries. So it's been identified that our powder has a lot of promise for solid-state batteries, since the properties of our powder don't exist anywhere else. So they check all sorts of boxes in neighboring applications that we're exploring as well. A couple of quick case studies. We touched on these a bit. This one here is BMW. So we've been working with them for several years. They were one of the references for our first venture capital round 14 months ago. So we've already increased the speed of their building by 68%. We have worked with another automotive company to print 3.5 times faster already. So we know from our internal testing and our own 3D printers in-house that we'll be able to offer them 4 times speed improvements shortly. So we're feeling really good about being the lead supplier for BMW. And BMW is the acknowledged leader in additive globally. They're the ones who do the keynotes at the different global industry conferences in additive manufacturing. This one here is a different defense contractor than we've named before. Approached us to solve a problem for making fine parts that couldn't be made for with other technologies or other powders. So we're very successful in improving the precision that was required just for their application to work. And we also made it faster at the same time. This is a bit of a history of the company. I think the key thing I'd want to communicate here is that, we started producing little bits of powder in 2016. Initially, it was enough to show people this is what it looks like. And we had, a lot more demand than we had ability to fulfill. So what we did year by year is that we had the notion to have customers sign material transfer agreements. So what that means is we would provide to them at no charge the powder, but all of the arising IP and any arising knowledge about the application had to be disclosed to us. So through the years, we managed to work with the leaders in aerospace, automotive, defense, and to be able to, all of the new IP around what it takes to make great powder for additive manufacturing has come to Equispheres, as well as the applications knowledge to be, to go in somewhere and help somebody and, triple, quadruple their productivity in the process. So today we have some incredible IP around powder properties where if it looks like our powder, it's our powder. So our patent filings basically identify that, look, if it's spherical and it doesn't have dust and it has these properties that we know are important to be successful out of manufacturing, if it looks like ours, then that's our IP. So we have several different filings like that, but it's really an elegant solution. So as we've moved through the years, last year we got to the point where we were shipping, hundreds of kilograms, which really helped us ramp up our qualification efforts. And this year, of course, our commercial reactors coming online, and we're starting to have their contracts to our strategic partners. So the second half of this year, I think, is going to be a pretty exciting year for us. We're getting quite a bit of international attention now too. A couple of weeks ago, we were featured in Metal AM magazine, which is the sort of the leading publication on additive manufacturing. So they featured us with an 8-page article. There was quotes about us from BMW and X1 and Trump and Divergent about working with, they disclosed they're working with us. You can see at the bottom, there's an interesting quote. This is what's really starting to be realized, is that key enablers of the growth are the material producers. Everyone now understands that even the best additive machine cannot deliver without the right powder. So that's sort of what I would generally argue, is that it's, who's going to win? Is it Desktop Metal? Is it X1? Is it HP? Is it SLM? Is it Trump? All roads would lead through to our powder to increase the productivity or even to make those technologies viable. So we like where we're at in the value chain. That top 3D printing startups box you see there. So I think I mentioned Desktop Metal was the fastest unicorn. There's been 2 or 3 unicorns in the 3D space already. So they had a list of 16, what they called mini-corns. It was a new word to me, but they had listed us as, out of 2,000 startups, they had listed us among the 16 mini-corns, or they're ones to watch out for, and the only material science technology company out of them all. And beyond that, I would just be reading, but we're getting a good ramp up now in terms of the more public validation about what we're doing. We have big barriers to entry. So we've obviously invested a lot to date to get to where we are at with some of the world's leaders in fluid dynamics and material science. So it's not easy to get to where we are. And if you did get here, I'd say, well, if it looks like our powder, it's our powder. So long lead time, we started again 2016, and we don't know of anybody who's any closer to doing what we're doing. The relationships, for a small company like us up in, Canada, to have that kind of traction with these world leading companies, if you were getting into the market today or as a second or third follower, it's pretty hard to break into companies like that to become a viable supplier. So, we feel pretty good about the relationships that we developed and the reputation. And again, that's a real flywheel of momentum, right? Because the better your relationships are, the more the more you're on the inside, the better you can accelerate your advantage. So this is the team. I won't read it out to you, but we have a very experienced team that I think is just right for the challenge. Everybody here has worked on different projects before through their career, and everybody here is really excited to make this an amazing Canadian success story. Our board, includes 3 different people that have grown companies from small to $1 billion. Without reading all the names here, but we have recently Keith Spencer has just agreed to join our board. One of Canada's leaders in IP. Rob Wildeboer, the chairman founder of Martin Rea, joined our board, agreed to join our board last week and be on the deck, which is great news. So we have I think, a very good board to help guide us going forward, and very active too. Okay, so Ruth, can I hand over to you for a moment?
Absolutely.
I'll do that. You tell me when to flip the slides. I'm here.
Will do. Okay, so the first thing that I want to highlight this afternoon is what our forecast is within the time period from today until 2026. But more importantly, I wanted to be able to provide for you some context of what the $256 million by 2026, how that looks in context with both the overall aluminum powder market and then to an even greater extent, the aluminum casting market. So the aluminum casting market is growing at a rate of about 6% a year. And so by 2026, we're thinking the market globally for casting is about $125 billion. That's how big it is. And the assumptions that we have made imply that the market for aluminum powder within this time frame will really only be a tiny portion of that. This isn't a really aggressive assumption that within this fairly short time period, it would take over that market, but it certainly begins to capture a part of it. And the second thing that I'd want to say is that Equispheres' assumptions with respect to what portion of that market we can capture are also fairly conservative, despite the fact that, as Kevin has very well articulated, our powder is far superior to the other aluminum powders in the market. The second thing I just wanted to emphasize that this chart brings out is the fact that in order to replace the casting market, we're well aware that there need to be modifications and improvements both to the cost of powder production, but as well the technology that uses the powder in order to get the cost down so it's competitive with the casting market. That's well understood and well known. And so what we think is going to happen over this time period, but even more impressively, if you look beyond this, is that the portion of the casting market that can be replaced as that cost decreases over time becomes more significant, and it's a massive market. Can I have the next slide? With this next slide, what I want to be able to emphasize for you is what our vision is for how you capture that market. What's our business model in order to do that? And so there's a couple of messages here. First of all, the growth from a very small amount of commercial powder to $256 million in this time period is going to be addressed in a couple of ways. First of all, internally, we intend to, build a small fleet of atomizers and reactors that are going to be able to address new alloys that we need to develop, as well as to address small niche players. But we intend to partner with contract manufacturers, foundries that already sell the aluminum, the most expensive component of the powder we produce. And by partnering with contract manufacturers beginning about 2024, we can really de-risk the supply, both by 2026, but certainly beyond, because they have the experience in supply chain management and the ability, low cost of debt, and the ability to manage the logistics that this implies. The second thing that I wanted to emphasize in terms of our vision is the fact that the concept would be that we would own the end customer relationship, and we would do that with our own team, but also we would be partnering with value-added resellers and channel partners over this time period so that we can begin to capture the portion of the market that's addressable. And finally, I wanted to say that we have a best-in-class R&D organization currently, and we will be continuing to grow and emphasize the importance of continuing to innovate and develop the technology to capture not just aluminum, this is just aluminum that we're talking about, but also to capture the other metal powder opportunities that exist. Kevin, can I get the next slide? Finally, I wanted to talk about the one of the most important things at any kind of plan like this is understanding how inexpensively you'd actually be able to produce the powder. And the key message from my perspective is that the concepts associated with the decrease in cost are not solely based on the idea that an increased volume is going to enable us to have lower costs. There are design changes to the reactor technology that will enable us to have better yields over time, longer run times, some of which are two of the key variables that impact the cost. In addition, there are strategies involved in this plan related to how the consumables that get used in the process and in the actual manufacturing process could be reduced. So structural changes are how we are going to go from higher costs to lower costs over this time period. I think that's it.
Okay. Thank you, Ruth. Is this a good time for Garrett or to Kenrick to jump in with some of the deal details?
Yeah, sure. I'm happy to jump in. So very simple cap structure, all common shares, but a 10% ESOP, $40 million raise, primarily going to R&D and plant equipment, which is what's going to drive down that cost of goods sold. And then scaling the business as well with working capital. EV midpoint is about 250, which is 14 times 2025 EBITDA, which is about 30% lower than what the comps are trading at before we added a 15% IPO discount. The metric being 2025 EBITDA is very common as the inflection point in the industry has started now with the technology that Equispheres has, as well as the X1s and the Desktop Metals with their printing technology, but it's going to take a couple of years for the adoption to pick up, which obviously is reflected in our forecasts. So again, very simple raise, $40 million, all common shares with a 10% ESOP at $250.